Graphing rational functions. This is just general information about the rational function, but the general rational function f of x is p of x over q of x, where p and q are polynomials. Here is the very general description. Okay, we've got a sub m x m. This is your leading coefficient. This is the degree. M is the degree of the numerator. And then this is just all the terms that come after it. Okay. A sub n x to the nth power. N is the degree. Okay, this is your leading coefficient of q. These are all the terms that just follow it. Okay. Your vertical asymptotes, those are the easy ones. Those are the first things you should always go for. Those are whatever are the zeros of the denominator. Okay, so you factor it, you set each factor equal to 0. Those are your vertical asymptotes. Okay, horizontal asymptotes, there's some rules you got to follow. And the rules have everything to do with the degree. So the degree, if the degree of the numerator, if m is less than n, then y equals 0 is the horizontal asymptote, period. Okay. If m is equal to n, so the degrees are the same, then y equals a sub n over a sub n, or a over b, if you want to call it that way. We'll say that's b. Where this is the leading coefficient of the numerator, this is the leading coefficient of the denominator. So whatever these numbers are, these two coefficients, this over that, that's going to be your horizontal asymptote. Sorry. If m is greater than n, there is no horizontal asymptote, but if m is greater by 1, say this is a 2 and this is a 1, or this is a 3 and this is a 2. If m is greater by 1, there is what's called a slant asymptote. Okay? You got vertical asymptotes, you got horizontal asymptotes. Well, then of course you're going to have diagonal asymptotes. That's a slant. They also call it oblique. It's on page 860 in your book. There is an example in your book at the bottom there, and it tells you kind of how to do that. So, starting with vertical asymptotes. Take x squared plus 2. That cannot equal 0. So, what can x specifically not equal? Subtract 2. X squared cannot equal negative 2. Is that ever going to happen? Is there a real number that'll give us, when you square it, a real number that when you square it, it'll be negative? No. Okay? So there's no vertical asymptote. Okay, no vertical asymptote. All right, horizontal asymptotes. We're looking at the degrees. The degree of the numerator, well, the degree of 4 equals 0. There is no x, so therefore the degree is 0. The degree of the numerator, the degree, or denominator, I misspoke, x squared plus 4 is 2. That's your degree. So the degree is less than, the degree of the numerator is less than the degree of the denominator. So we've got m is less than n, so y equals 0 is your horizontal asymptote. Okay? So when we graph these, okay, there's no vertical asymptote to graph, but the horizontal asymptote, kind of just sketch that in there. Then we got to figure out, okay, what's going to happen here. So we pick some numbers. And you can use your graphing calculator for this if you want to. But if you don't have the graphing calculator, then just pick some numbers. Like, let's go with negative 3, negative 2, negative 1, 0. And then 1, 2, 3. Okay, plug here, here, 4/3 is here, 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 here. There's our graph. And if you graph it in the calculator, you'll see all that good stuff. 3x squared. Start with your vertical asymptotes. So x squared, and it might be easy to factor. X squared minus 1 will factor to x plus 1, x minus 1. And then you set each factor. Each factor cannot equal 0. So x plus 1 cannot equal 0, and x minus 1 cannot equal 0. So x cannot equal negative 1, and x cannot equal positive 1. Vertical asymptotes are at positive and negative 1, where x equals positive and negative 1s. Horizontal asymptotes, the degree of the numerator is 2, okay? The degree of the denominator is also 2, so m equals n, so y equals a over b. This is a, this is b, so y equals 3 over 1, which is just 3. There's your horizontal asymptote. Sketching, you must get the asymptotes on the graph. So we've got negative 1, positive 1, and 3. Okay. Now, what I would do is I would use my calculator to figure out where my curves go. But if I don't have the calculator, then you just pick some points. Okay, so if we pick all these points, we plot them, we plug them in, blah, blah, blah. And then we can graph them. I am going to use my calculator. When you put these into the calculator, it is very important that you put in the entire numerator and denominator in parentheses. So we got 3x squared divided by x squared minus 1. Okay, and when we graph it, the graph looks kind of crazy. This is on the TI-83. But I think my window, I've got my window set kind of different. So if I hit zoom standard, it might look a little nicer. Okay, I can see that I've got a graph. I've got two curves here and here, and then I've got like a parabola in between. The calculators put in, some of the calculators put in the vertical asymptotes. Some of them do, some of them don't. So basically we've got this here, and here, and here. Okay, that's all. That's what I'm looking for when you sketch these graphs. I'm not looking for perfection. And again, if you didn't have the graphing calculators, you just plug in the numbers and do the math. So like negative 3, plug it in here, and it's going to be 27 over 8. Negative 2, it's going to be 12 over 3, which is 4. Okay. And you can just continue out that way. Here we've got vertical asymptotes. With this one, it's going to be x minus 4 cannot equal 0, so x cannot equal 4. That's called the point of discontinuity. We're going to talk about that in a minute too. So the line x equals 4, that is the vertical asymptote. I should have been putting it to you like that from the beginning. My bad. Then horizontal asymptotes. Is there 1? The degree here is 2. The degree here is 1. 2 is greater than 1, so there's none. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. But how much greater? This is a 2, this is a 1. It's greater than by 1, so that means there is a slant asymptote. Okay, because the degree of this is a 2, the degree of this is 1. It's greater than by 1, so there is a slant asymptote. How do we find that? We find that by doing division. So we're going to set up a long division. Remember long division from chapter 5? X squared minus 2x minus 3. Okay. Why do I use long division? Because you're not always going to be able to divide with synthetic division. What do I multiply x by to make it x squared? X. Then you multiply. X times x is x squared. X times negative 4 is negative 4x. Then you subtract. These guys cancels. Then negative 2 minus negative 4, well, it becomes negative 2 plus 4, which is 2x. You can bring down the next term. What do I multiply x by to make it 2x? We're going to multiply it by plus 2. This line is the slant asymptote. Okay, so that line is the slant asymptote. X plus 2. And you graph that line for the slant asymptote. So we have the vertical asymptote at x equals 4. And x plus 2. Y-intercept, this is y equals mx plus b. Y-intercept, your slope is 1. Okay, so up 1 over 1, up 1 over 1, up 1 over 1. There is the slant asymptote. And then you got to figure out, okay, I'm going to have two curves. There's going to be two branches here. Are they going to be here and here, or are they going to be here and here? Okay, to find that out, well, one thing you could do is factor this, because the zeros of the numerator are the zeros of the whole function. So if we factor x squared minus 2x minus 3, that's going to factor to x minus 3, x plus 1. Okay, so negative 1, here is a 0 and positive 3. So my curve is going to go through here somehow. So that means the other branch is going to be up here. Okay. And again, you're going to have mirrored branches. They're going to be opposite each other. They'll, like I said, they'll either be here and here or here and here. Most likely here and here. Okay. And again, you can use your graphing calculator if you have that yet. If not, then just plug in points and find them. Exactly, you just plug in points. To plug that in, I'm going to put x squared minus 2x minus 3. That's going to be in parentheses, divided by x minus 4, and then graph it. Okay. Vertical asymptote, notice that other branch up there isn't in this graph, so that just means I got to zoom out a little more, which I'm just going to change my window. I want to make my x maximum a little higher. Take it up to 20 and see if we find it yet. There it is. And if I graph the line x plus 2, it's going to go right along here. Watch, we can plug that in to our y equals x plus 2. That's the slant asymptote. Look, there it is.